Hello viewers, welcome back to Ani Codes. In the last lecture we saw the introduction of C language. Today's topic is the structure of a C language. Have you ever wondered about programming language having structure? Yes, you are going to learn in this chapter. Before getting into the details, let me explain to you a known concept, that is, how do we learn any new language? In the process of learning a new language, first step is knowing about the alphabet, framing words by using the alphabet, followed by sentence formation and paragraph formation. After learning all of these, we try to communicate in the new language formally, hence, we write a letter by following proper structure. The letter format contains like heading, date, from, to, subject, body, and your faithfully. Similarly, C language also follows a proper structure, as shown in the figure. C program structure consists of the following: documentation section, link section, global declaration, void main function, local declaration, initialization, operation, output, and subprogramming. This structure is applicable to other programming languages, like C++, Java, Python, etc. Let's discuss about documentation section, which is also called the comment section. In this section, we try to provide the title of a program, which is written on top of the program. This section is very important, because, if somebody opens your program, it will act as a proper guide to them, and understand the program properly. Comments can be given in two ways. The first one is, in this format. This symbol is called / and the symbol is called asterisk. The second one is double flash. This kind of comment section is used to write multiple lines comments. This kind of comment section is used to provide single line comments. The comment lines can be provided anywhere inside a program wherever necessary. The compiler checks the program and ignores these comment lines. In this comment section, you can make any mistakes like spelling or grammar mistakes and the compiler will not raise any error. Let me explain to you with one example. Someone asks you to write a program to print your name and screen. This whole question can be used as a heading for this program. If someone opens this program, they will understand that this program is written to print your name and screen. Without this comment, one has to read the entire code to understand this program. So you can write this question inside these comment lines by providing a / and asterisk, followed by the message and asterisk, /. Moving on to the link section. In programming, the link section is where we include C language libraries known as header files. These header files provide access to predefined functions. For instance, without including the stdio.h header file, we can't use functions like printf and scanf in C. These functions are part of the stdio.h library, which stands for Standard Input-Output Header File. Similarly, when we need mathematical functions, we include math.h. And for string-related operations, we use string.h. These header files give us access to various functions related to math and strings. Global variables are like messages that can be seen by all parts of the code. They're declared outside of specific functions and are available everywhere in the program. It's like having a big signpost that everyone can read. Local variables, on the other hand, are more like secrets locked inside specific functions. They're declared inside these functions and can only be used there. They're like private notes that only that function can read. In a C program, the void main function is the starting point. It's where everything begins. First, it sets up things by initializing variables. Then it carries out operations or tasks. Finally, it shows the results or output. So, think of it like this: the void main function is the director of a show. It gets everything ready, initialization, tells everyone what to do, operations, and finally, presents the finished product, output. Subprogramming, similar to a user-defined function, enhances code readability by organizing tasks into smaller, manageable parts. However, I'll elaborate on this topic in more detail later. In summary, global variables are like messages visible to all parts of the code, while local variables are like secrets known only inside specific functions. The void main function orchestrates the whole program, getting things started, doing the work, and showing the results. Understanding how these variables work together in programming helps us create amazing things with code. When writing a C program, remember these key points. Use only lowercase letters for your code. Every program should contain a main function, as execution begins from there. Each line of code in C programming is referred to as a statement, and it must end with a semicolon to mark its completion. Before diving into our first program, let's understand printf and scanf. Printf is akin to a train or metro display board, showcasing current and next stops. In programming, it's used to display messages on the screen, each message being similar to a printf statement. For displaying values, the syntax requires following specific formatting rules. However, when displaying a message, only the message itself needs to be written. Similarly, scanf is used for getting values from the keyboard. Its syntax demands using only format specifiers without commas or spaces. Now, we'll create our first program to print your name on the screen. Before writing program, think about what's needed for inputs and outputs to accomplish this task. We'll adhere to the structure of C programming, starting with the documentation section where we title the program as printing name on screen. Then, we include the standard input-output library using #include stdio.h. Since no variables are necessary for this task, we proceed directly to the printing step. To print the name on the screen, we'll use the statement printf, on ecodes. This single line will display the name on the screen. Once we've written this straightforward program, we'll proceed to execute it within an integrated development environment, IDE, such as code blocks, VS Code, Dev C++, Turbo C++, etc., opting for Dev C++ for our demonstration. The execution process and handling any encountered errors will be explained in the subsequent chapter. And our first program has been successfully executed. If you like our videos, please like, share and subscribe. If you need any content suggestions and improvements, please provide them in the comment section.